What?
You get used to these things. I guess.
Usually there's a clip and it clips on
they
there.
lost the clip. I don't know what to put.
Yeah, so I'm not used to the tape, but the microphone, I swear these things more times than I like. All right, so I was going to put a hands-on DNS testing into this section. I'm going to skip this and move on because I want to make sure we cover all the material here. So forgive me while I skip this. Do go back, look at the slides, they'll be posted, and do these tests for yourselves. Like I said, element of personal knowledge in any form of engineering and science. There's a couple other hands-on. We're not going to abandon them all, but I'm going to skip this one because we're already past DNS. So, anti-pattern. It's out of my control. I can't do anything about DNS, and you know, TCP connections are kind of up to the server, and SSL just kind of, you know, it does what it does, and I can't do anything about it. And those database calls are fixed, you know, I can't figure out any way to do it. There's not much I can do. And some of this stuff's outside my control. I'm just going to let the user hang. I don't care, you know, it's like, hey, it's only my paycheck. I'm just going to go off in despair. And just throw up my hands, say that's outside of my control. Do you see people do that? I do, a lot of times, especially when it comes to performance. So solving T1 problems is hard. How are you going to fix DNS? How are you going to improve TCP IP times? Right? Improving T3 times is hard. Right? How are you going to make TCP more efficient, make it get there better? Improving T4? Almost impossible in some sense, at least, because you have no control over what the user does or what kind of hardware they have. We already know about improving T2. And there's just a whole lot of things that are outside my control. Why shouldn't I just walk away and say, yeah, there's not much I can do about it. And hey, my competitor over here, he's just as clueless as I am, just as despairing, right? Has the same rock in his yard, right? And he's not doing anything about it. Why should I bother, right? I can't do anything about it. It's outside my control. Does this sound helpless? Does this sound pathetic? Because it is. It's absolutely pathetic. It's never the case that there's nothing you can do. Don't tell me that there's nothing you can do to make this better. Even if you can't fix that problem, you can compensate somewhere else in the overall E2E. And don't tell me there's nothing that can be optimized on your website, because that's just not true. Everybody has something to optimize. When I hear people say that's outside my control, normally, that's a manager who does not want to spend money and time solving something because it looks complicated and it doesn't fit with his quarterly goals. That's what that statement means. It doesn't mean there's nothing I can do about my web page. It doesn't fit into my plan. And I don't feel that that's acceptable. The web is here for the end users. It's not here for Google or Facebook or any of these guys. And those guys never miss an opportunity to optimize. I don't want to pick on them, right? But website X that doesn't spend any time optimizing or feels like the steps they have to take to optimize are too difficult, outside their control, that's just despair, and we don't do that. No matter what, there's always something you can do. Maybe it means taking some crap off of that page if you can't find any way to make it faster. I know that never occurs to anybody. Taking stuff off the page just never seems to happen, right? There's always a way to fix it. I don't want to hear from my engineers, that's outside my control, I can't solve that. No. The right solution, think outside the box. Compensate in some other part of the E2E. If you can't move the server closer to the user, can you move the user closer to the server? Sounds crazy, but hey, maybe it might work if you run a mobile cafe, right? Think about Starbucks. They have bad performance problems. Maybe they can just rearrange the chairs or move the wireless AP around, right? There's always something you can do. But when people say, that's outside my control, I'm giving up, at that point I flip the bid on that person. I go looking for somebody else who can actually solve the problem. So don't fall for this anti-pattern. No keyhole optimization, no whining about it's outside my control. There's something you can do. Think hard, right? You're a user. You hate it when it's slow. Who here hates it when the web is slow? Come on. Okay. Seriously, right? Are you going to let some user wander off with a bad experience when you could have done something about it? I mean, okay, admittedly, I'm one of those people that can't see a problem I don't want to fix. But I don't believe in this it's outside my control thing. Do something about it. All right, tools and testing. Let's talk about some tools. There's basically two classes of these tools. There are the commercial testing services. I don't know if anybody in here has any experience using Gomez, CompuWare's product, Keynote, Thousand Eyes, AlertSite. Anybody used any of those? Okay, one person. And that's normally, so that's not unusual. I come into these classes and I ask this question and nobody is familiar with the commercial tools. And what I've discovered is that unless you work at a company with far too many employees, they don't have the money to pay for these things in most cases. Right? So I go to Yahoo and I go to Google and I go to eBay, and of course they have, 4 or 5 different services. I think at eBay/PayPal we have AlertSite and CompuWare and Keynote and Gomez and every other measurement tool you can possibly imagine, right? Which doesn't make anybody's life easier having too many tools, trust me. But what I find is that the tools that are best used to help people aren't available to them for commercial reasons, and that sucks. Right? I've talked to the CompuWare guys about this. I have a long relationship with CompuWare. I worked on their last mile product at one point and helped them develop some file formats, have a long relationship with them. And I said, the one key problem to making the web faster is just that you guys have the data and you don't tell anybody about it. And I was really disappointed. I never got any sort of response to that, even though it's true. Be that as it may, these commercial services exist. They're designed to do wholesale testing on websites. They're very sophisticated in a lot of ways. In other ways, they're kind of dumb, right? But they have some level of sophistication around them. They're often used for monitoring, which is different than performance management. Monitoring is the business of making sure things work reliably. Not how fast they work, but just that they work at all. Right? And these tools are very good for monitoring as well. In some cases, they're better at monitoring than they are at measuring performance. AlertSite's a good example of that, right? They're really good at finding a problem, not so good at telling you this is what you need to do to make your website faster. CompuWare does continue, in my opinion, and this is only my opinion, to have the best tools in this business. That's why they're listed there first. But regardless, if you're in a situation where your business or you have access to one of these, they're great tools. And they've done a lot of thinking about how we want to test things on the web. And even if we can't use their tools, we're going to borrow their thinking and their methodology and learn from their mistakes for the testing that we do. One of the things I do in my book is I show you how to set up an alternate testing service very similar to these commercial services using AWS, and it costs you nothing. Well, it costs you something to run it in AWS, but it doesn't cost nearly as much as an enterprise-level CompuWare account. So that'll be in the book. I'm obviously not going to spend a lot of time talking about that here. Wholesale testing, statistical data. I had that whole section on statistics. You're wondering why I was doing that. It's because performance is a statistical activity. You can't do much reasoning about any individual's performance measurements. This is operational testing. You can't use these tools to test things before they launch. I mean, some of them have separate QE or QC tools that are separate, but the performance testing tools themselves only work after something's launched, right? Which is exactly the opposite of what you want, right? I mean, once it's launched, it's a little late to find out that you have a performance problem, right? We want to test these things first. And it's really, really good with these commercial services for understanding the international measurements. It's nearly impossible to figure out how fast your web page is in Peru without one of these services. Now, the W3C's recent specs on navigation timing and resource timing offer us some alternative ways to actually get at those international measurements or those measurements from areas where you don't have points of presence, but it still doesn't work very well. If you want to know what's happening in Peru or Paraguay or the Philippines or, Uttar Pradesh for that matter, right, you're going to need one of these services. Calling your buddy in Uttar Pradesh and saying, hey, can you measure how fast Yahoo is today? Will obviously not work. Right? So these commercial services fill a goal that cannot easily be filled in any other way. They are costly. I was really surprised. I negotiate the contract for these things for my employers, for the last 3 or 4 employers. And I'm always surprised at how much these guys get to charge for this stuff. It's like I'm going into the testing business. We'll talk about those tools. Desktop tools, things that you can do without paying any money at all. So that sounds good, right? At least the part about not spending any money, but very limited in what you can learn about your user's performance using these tools. They're mostly spot tools, tools that you use on your desktop. You can use them for diagnostic purposes, right? Any test you make from your desktop, whether it's at home or work, it's not valid data. Individual data points are not, subject to inference, right? You have to gather a lot of data, and most of these personal tools don't make that easy, right? So they're limited. And to really do serious performance management at a commercial level, you're going to need to engage one of these commercial services one way or another. But talking about the page analysis tools, obviously the first vote goes for YSlow, because it was developed by my team at Yahoo, and we're all very proud of it still many years later. And so YSlow is awesome. And basically what YSlow does is it's actually a plugin to a plugin. And believe it or not, it's a plugin to the Firebug plugin for Firefox. And it has other instantiations at this point as well. There's a mobile bookmarklet and some other stuff. But basically YSlow monitors what happens when your page loads and draws you a little waterfall. Looks pretty much like that other waterfall we looked at, and then you can go ahead and analyze your page performance. The same result can be achieved in 2014, mostly just by hitting F12 on your browser. Try it. Right? You bring up the developer tools. No? What browser do you use?
Chrome.
Huh? Chrome? Yep. If you hit F12 in Chrome, you will get developer tools. If you don't, boy, I know who to call. I don't even have to call anybody. Right over there. So is everybody familiar with the developer tools, or at least seen them, knew they were there? Okay, so 3 years ago, if you hit F12 in your browser, nothing happened. Right? Now, every browser has these very nice developer tools built in. You can thank the guys at the Mozilla Foundation for that. They were not very happy about plugins to plugins in Yahoo coming up with YSlow, so they decided to build this functionality directly into the browser. And, as partial as I am to YSlow, I appreciate the fact that they built that into the browser and that all the other browser manufacturers have made this available to us. There's some problems with it. If you want to analyze SSL data, yes, SSL is near and dear to my heart. You figured that out by now. If you want to analyze SSL data, can you use Chrome? No. Can you use IE? No. Can you use Opera? What about that thing Apple makes? What's it called? Safari, right? Can you use that? No. Only one browser will help you analyze SSL problems, and that in itself is a problem. It's called Firefox, and the Firefox guys are smart. They actually have to debug stuff for themselves sometimes, and so in the Firefox developer tools, as opposed to Chrome and IE and the various others, you can actually see the OCSP lookups. You can see how long it takes to actually make your SSL connection, certificate exchange, and all the other details that you need to debug it. This is the only browser that actually provides that information. Why that's the case is based on some strange ideas about privacy that the browser manufacturers have, as if putting that into my browser somehow violates my own privacy. Go figure. It's not an argument that I've ever bought. But be that as it may, you've got a nice tool. Hit F12 in your browser. It doesn't meet every need. There's lots of things that you can't do with the developer tools. It's nice they're there. Keep working on it, guys. There's some other tools. Microsoft came up with a tool called Virtual Round Trip Analyzer. It was written by a guy named Jim Pierce, who's actually the performance expert, believe it or not, for Microsoft Office. And why he wrote that tool is about making Outlook go faster. But this is a great tool. It not only gives you the waterfall, but gives you the packet breakdown and shows you the packets associated with the individual HTTP requests, which is very useful. And is the only tool I know of that will allow me to do that. Otherwise, I've got to whip out Wireshark and some other tool. So VRTA is a great tool. Like I said earlier, they've ceased to support it. You can still download it. Just search for VRTA, Virtual Round Trip Analyzer. HTTP Watch is a standalone commercial product. It's a plugin, or it has a plugin for your browser, and it just sits there and monitors the activity in the browser, much the way that Firebug or other things do, and gives you the breakdown. It has some very nice waterfall diagrams. We'll see that earlier. It has some fancy features, let you record what actually happens, which is very useful once you want to put it into a database and record thousands and thousands of HTTP requests. So HTTP Watch has some good points as well. There's also this new area around retail testing where we're really testing a single page or a single app. We're not testing thousands of users. We're not testing large scale internationally. We're doing diagnostics. We're doing functional testing. These tools are most useful before you launch. You can look and see what's going to happen, more or less, right, when you go into production. And you can fix things first, bake it in up front. The only other case where these tools are really valuable is in that diagnostic case, right, where there's a problem, and by looking at the waterfall or some of the associated data, you can say, oh, look, that image is getting a 404. This particular script did not run properly. Diagnostics. Right? It tells you nothing about how fast your web page is in India. No amount of using these tools will ever tell you that. To know something like what's happening in India, or what's happening in Uttar Pradesh, or what's happening in Bali, or give me an Indian city, Chandigarh, right? Something like that. I've got to whip out one of these tools, or I've got to be clever and imitate one of these tools. There aren't any other choices really. Commercial testing services are really helpful. All of these things are very similar. There's really only one methodology for testing performance. I mean, this is science. How many methods are there for titrating acids, right? There's really only one methodology. There's variations. The Keynote guys like the geometric mean, and the CompuWare guys like the arithmetic mean. It's not a big deal. Mostly their test nodes are in large data centers. Remember those backbone nodes I showed you on the diagram, right? Most of the time, the testing takes place from there. So here you have a data center. It's run by AT&T. AT&T provides the DNS service. There's undoubtedly an Akamai node somewhere in that data center, right? And we're going to do a performance measurement from that data center. How valid is that? How useful is that when no user sits in any data center? I mean, when was the last time you sat down and started surfing in a data center? Come on. Right? Backbone measurements performed by commercial services are also diagnostic in nature. They cannot tell you what happens to real users. And when you take real user measurements, say by setting up the test node on a user's machine, and CompuWare does this actually for their last mile product, they actually pay people a nickel a test to run performance tests on their machines. And they just download a little package of software, and they say, we're going to send you a schedule, and every time you do a test for us and send us back the results, we're going to give you a nickel. Right? I offered, do you think you could get more users if you gave them a dime? I'm serious. I was going to, up the price just to get more users, because this data is so valuable. I get to see what happens in the real world to real users, right? And that's where I get my money. Statistical data about response times is all we can gather. So for this particular graph, well, you could guess it's SSL, right? I mean, hey, I'm the one showing it, so it's got to be SSL, right? In this top graph here, I actually did something clever. I plotted SSL response times versus the standard deviation for SSL response times. Now, every time I explain this to people, they look at me funny. It's like, standard deviation's a number, it's not a function. How did you plot it? And I'm like, looks like I drew the line on the graph, right? There's no reason you can't plot standard deviation as a function of time, right? It's just a function of the response time. So that's what you see plotted here, and you can see that every place there's a peak. By gosh, there's a peak in the variability. I mean, there's nothing magic here. What I wanted to illustrate with this graph for the people that I was showing it to was the high level of variability in SSL response times. As you go through here, this thing is just bouncing around. I have an equivalent graph that shows one of my friends and competitors, and I won't tell you which one, same graph, that didn't show all that variability. Right? Line was much smoother, didn't have all these crazy peaks and stuff in it. And I went and showed that to people, and I said, these folks are calm, they're tranquil, we're all over the place. Let's go fix this. And we did, and that's kind of what we went and fixed. But this is the sort of thing you can only do with these commercial services. You can't do that with retail testing. It requires lots of statistics. Here I plotted the margin of error. Most people never see that sort of thing plotted, but what I did is I just plotted the envelope around the individual data points, right? And I'm 95% confident that the real value lies somewhere inside that light gray band. This is a pretty common way of writing error margins on graphs. But does that make sense? So you see that everywhere that the graph goes up, the margin of error goes up, right? Because remember, the margin of error depends on the standard deviation and the number of data points. Number of data points isn't going to change, but every time the peak goes up, the standard deviation goes up. We expect the margin of error to go up as well for that individual data point, right? It's an important point here. If we say we're 95% confident about the value of this data, that means we're 95% confident for the entire data set. It does not mean that for this data point, I am 95% confident, or that I am as confident about this data point as I am about that one, right? Some points are less likely than others. It's just pretty straightforward, right? And here you can see the response time went up a little bit. Margin of error went up pretty considerably around that as well, because the standard deviation made it go up. Where things are variable, errors accumulate, right? The bottom line is that to do this sort of sophisticated analysis, you really need the statistical data in those commercial services. Testing locations, obviously the #1 spot, center of the universe, your QA and test labs. Don't launch anything without testing it, please. I mean, please, seriously. You're not gonna do that. Okay. So the next line of measurement testing is your own data centers. You should do performance testing inside your own data centers. No, there aren't any users sitting there, but if you're going to find a problem, you would much rather find it yourself, wouldn't you? Right? I mean, once you get out here onto these public nodes, these are the backbone nodes. These are these large data centers run by AT&T and Sprint and these folks. And you know, the commercial services have test nodes out there, no problem. I can test from AT&T's center in Denver, no problem. And I can find those errors much better if I'd found them myself than to have somebody at Gomez or CompuWare call me and say, oh, by the way, you know, by the time your data got to Denver, this link was broken. We happened to notice, you know, maybe you ought to call your QA people. No, I don't like hearing that. The end user lives out here in the last mile segment. He's the one we care about, right? The whole class focused around the user. Last mile, backbone, data center, QA, and test. These are the only 4 important places where you can get performance data in the course of launching your product. Which one do you think is the most important? You already answered one, so I'm not going to pick on you again. I'll pick on the guy behind you. Which one's most important?
Of those 3?
There's 4.
Oh, I'm sorry. I say QA and test.
Very good. Anybody think anything different? Right? You want to find the errors before the users find them. Right? That's a failure. When a user finds an error that you could have found, that's a failure. And you should go home and mark that one on your little chart. You know, I mean, everybody's got a list of the things they screwed up, right? That's one of them. Bake it in up front. Performance is a design time activity. It does not take place after the product is launched. If you're solving performance problems after the product is launched, that's a fail. Seriously, it's like by the time these commercial services are useful to you, because the product is already in production, you should not be finding performance problems. They're really there just to make sure that everything is predictable and reliable. And if you have to fix something because you found it in a last mile measurement from CompuWare, you have screwed up. The end user found the error before you did. And that's the exact opposite of what we want to happen, right? Right? We find the errors. There are errors. We find them. We fix them. No user ever sees them. So the commercial services have tests at all these different places. And one of the beauties of using these commercial services is usually it's the same test mechanism. So you can now compare the data taken here, 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 and here. If you're actually clever and set your network up so you have the same test nodes in all 4 locations, suddenly you have complete visibility into performance globally, everywhere that you could possibly measure your performance. There's nothing else you can measure. And as far as measurement setup, you're done. You're good, right? But the most important one is that QA one before any user sees it, right? Measurements taken in your own data center and at the backbone, not so much worthwhile. No users ever sit in these places. The network conditions, the management of those networks, everything very different from anything that any user experiences at home. In fact, I tried to prove to myself it was possible for a packet to take the same route through the network from a data center that it does through my house, and I couldn't convince myself that there was any case where the packets would even follow the same set of paths, even partially. It's just not possible. The experience inside those data centers is so different from anything any end user expects and works so well in comparison to everything that end users experience that the data here is diagnostic. Once again, if you want to learn what's really going on with performance, you want to run the numbers T1, T2, T3, T4, go fix your website, you need to understand what happens to end users. No amount of looking at the backbone data is going to solve those problems. What you'll find is that you take your backbone data, you identify what you think the problems are, you go and solve them, you go and then measure people at the last mile, and your performance is not improved because they have a completely different set of problems than the ones you thought you had when you were sitting at the backbone. And I've seen this happen many times. Response times can double between here and here. And that's crazy. Right? I mean, in my house, cable goes from all the way from my house right into to Google's data centers. Pure cable path. There's no copper anywhere along there. But my response time can drop by half from here to here. Why that's the case is subject for another lecture. But seriously, there's a lot of difference at the backbone and the last mile. Don't let somebody tell you, oh, backbone data is much cleaner, it doesn't have as much outliers, you know, the variance is so much lower, we'll use it for our performance testing. No, insist on getting data about what happens to real users in the real world with real mice and real mobile devices in their hands. HTTP object model, I'm not going to belabor this very much, but a test is a sequence of URLs. Page is obviously a sequence of page objects. Each page object has some associated time segments. This is just a model for how we would store this data in the database. I don't think it's truly important for this class, so I'm going to skip past it, make sure we get through everything else on time. Desktop tools, here's our beloved YSlow. Basically, you've got some Unix command line tools. These are the things I talked about earlier. Please make sure that you always have access to these. I feel naked if I don't have my ping. And seriously, you should have it on your phone. You should have it on your machines. If you can't run things like ping and dig and so forth, you're not going to be very happy. Curl, obviously. And then there's an online test tool called webpagetest.org. This is sort of a tool of its own kind. It's neither desktop nor commercial service, sort of a difference between them. Really quickly, once again, the Unix testing tools, ping, NSLOOKUP, traceroute, netstat, and curl. Curl is the only one that won't be installed by default if you're using a true Unix or Linux system. That includes the Macs. You may have to install curl. If you use Windows, or if you're using a mobile phone, you're going to have to go and find these things. Cygwin works pretty well. There's other various ports to get these commands, but you need to have these no matter what platform you're using. And in the real world, most people use Windows, and they use IE. Well, maybe not so much anymore. I think Chrome has pretty much wiped out IE at this point. But most people use Windows. If you're a Mac user, it's very difficult for you to have any insight into what happens to users on the web, just because your experience is so different. Right? Mac users they have a different experience of the way things work on the web. And seriously, I encourage performance people, even if you don't use Windows and you can't pry your Mac out of your cold dead hands or whatever the saying is, get a Windows machine just so that you can get some empathy for what happens to users in the real world that are using Windows machines, because they have a different life and it's a very different experience. And as a Mac user, you're going to be surprised at what happens. Seriously, don't sit there on your Mac, test performance, pretend that's what happens to people in the real world, because the people in the real world are using Windows. Macs are about 5% of the install base, not in this room, obviously, but in the real world, 5% of the install base. 95% of the people are using Windows. And the rest of the machines don't even matter.
What about using VMware and then Windows on VMware on my Mac?
So it's a great question. The short answer, doesn't work. The way that the VMware layer underneath, the MX layer underneath it works is it partitions the network card, essentially the Ethernet port. So there's a limitation on how much bandwidth you can get in and out of that VM that's embedded inside the Macintosh OS. And basically it's just artificial network conditions. Right? I see people do that, and you know, if you use a Mac, it's okay. It's like, it's better than not doing any testing at all. Right? And it gives you some sense of what Windows users face. When you're looking at the data from that, I would assign a higher variance to the quality of the data. Right? I don't want to put you off of it. If you're a Mac user and you don't have a Windows machine, that may be the best you can do. I want you to go into it with your eyes wide open. It's actually pretty interesting. I'm a Windows user, and even though I'm standing up here with a Mac, my Air runs Windows really well. And, and so I was sitting next to the guy from Apple at the W3C's tag meeting in November in China, and I whip out my Mac, and it made the Windows sound. You know, ding, 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 ding. The guy just looked at me like, that was a precious moment. It's like Mac opens up and makes Windows sound. WebPageTest.org. This is a service that's provided by the folks at AOL, amazingly enough. And they've set up some test nodes in various data centers in various places. They have their own software. It's called WebPageTest, amazingly enough. There's a desktop version. You can go and download it onto your desktop. It's a just normal piece of software, not a website. It's very useful to download that piece of software and then go use the online version and compare your results. You can get an idea of just how bad your personal results are compared to what happens in the real world. But anyway, webpagetest.org is free. Works in a way similar to the commercial services. Definitely provides some of those services. You can't gather hundreds of thousands of data points and do the statistical analysis on them, but short of that, webpagetest.org is pretty much equal in functionality to most of the commercial services. And in some cases actually does better things. You can set up your own set network of web page test nodes in Amazon and build your own CompuWare, your own Keynote. And in my book, I actually show you how to do that, because I can't afford to go and do CompuWare either, right? Unless if I didn't work for a big company, I would have never seen it or known it existed. I want to give people some power to build their own tools if the industry is going to force us, you know, is going to overprice things that we really need. The data that you get from these tools is gold. This is the only way we improve the net. And charging a fortune for this data and not making it public to everyone injures all of us, right? It's not just about other people. We share a network. That's what network means. All right, waterfall diagrams. I think everybody has seen waterfall diagrams, but I want to give you a sense of what webpagetest.org does. So go there in your browser. Pick your browser of choice. I don't care. But go to www.webpagetest.org. Anybody having trouble getting there? It's all straightforward. All right, so let's look at Yahoo this time, because I picked on Twitter last time, and I try to pick on individuals, you know, in a fair way, or companies in a fair way here. So let's pump in Yahoo. So this is a much more recent version of the Yahoo homepage. It's been improved since the one I showed you last time. And no, I won't go there. But the So this is a much more recent waterfall, and this is from webpagetest.org. You can see that it looks somewhat different in the sense that, A, they've used different colors. So once again, as this gentleman was pointing out earlier, we have a design color problem where all the colors are a little crazy, and you could do a better job designing that. A couple other things that are important about the WebPageTest waterfall. They very clearly mark out where the initial 0 of the measurement is, and they very clearly mark where the browser calls time, right? So at some point the browser says the web page is done now, right? And that's actually marked here by this purple line, or this green line, and then this is a further event that happens later that means more or less final completion, right? There's actually two events that the browser sends that, that indicate levels of completion of the page load, and these guys very nicely mark them both for you. What good is that? I want to know if my deferred loading works. Remember, I decided in my three-step process for loading web pages, I was going to download the base page, then I was going to download the static stuff, and then I was going to wait till the page loaded and then do all this deferred loading for ads and beacons and whatnot, right? So how do I know when the web page is done loading? Well, when this event fires that you see here in the line, then that indicates that event is fired. And if you wait until that event fires to fire your stuff, it won't interfere with the user's performance. That's the whole heart of deferred loading. You can see here on Yahoo's waterfall that it's a big fail. Didn't manage to get the deferred loading to wait until after the onload handler fired. And so all the deferred loading stuff loaded before the onload handler fired. And this was actually an error case. Normally that can't occur. I was busy testing an error case trying to figure out why this was actually happening to generate this waterfall. In most cases, and probably on your screen right now, you'll very clearly see that some stuff launches after the page is loaded and some stuff before. And usually pages try to make that very clear. So has everybody punched Yahoo into web page test and got a waterfall? Okay, so go to your waterfall here for a minute, would you?
I was looking at PayPal.
Ah, you don't want to look at that one, man. No, yeah, no. So you can see that our SSL is considerably better.
Yes.
Right, so the other thing there that's, so you can't just type paypal.com into that bar because we require a secure connection. So we did a redirect from HTTP to HTTPS, and that cost us 400 milliseconds. Okay. So with a secure site, type explicitly the HTTPS, otherwise you're costing yourself performance.
Right.
Yeah. Okay, so we're waiting on yours. Let me see if I can find somebody who has a waterfall. Ah, this gentleman's got a great waterfall. That's a beautiful waterfall. So you can see here that this line indicates that the browser is finished, and these things all started at exactly that time.
What about those?
So the base page loaded here.
Okay.
Right. Then we started downloading stuff from the CDN, right? So see here, it loaded 4 connections. Remember I said the browser connection constant was 4? So Y image is Yahoo's CDN. So you can see we open 4 connections and we start dragging stuff down. And you can see all of this stuff starts at the same time here, right?
Here it says start render.
Yep.
Rendering.
Yep.
The page itself. Okay.
Yep. And then blue is document complete. Right, so you can see all this stuff loads after the document is complete. That's when we load the ads, that's when we load the beacons, and we do that so that it doesn't interfere with the user's response time, right? Because response time basically ends when we call that onload handler. And the time after that we basically regard as free time, right? Really what it is it's the user's think time, right? You're busy reading that page and we're busy beaconing back information about how long it took to load and what you did and so on. But that's so that's one of the things that this tool does that I really like is that it marks the time for document completion on the waterfall. Yes, sir.
Is there a way with this tool to use a site that requires a login? In other words, you have a site that requires a login, authentication. So you have to.
So probably not with webpagetest.org without a little work. So you could definitely do it. You're going to have to do a little bit of JavaScript programming yourself to make that work. It's 15, 20 lines of JavaScript. What?
There's an off tab at the beginning.
Oh, is there? Did they add that? Ooh, is it post-based?
I believe so.
Is it post-based? Oh, very good. Okay, so never mind, I stand corrected. This guy is now teaching class. No, I'm just teasing. But so they've added this auth tab here. Where was that?
Advanced settings.
Yeah, advanced settings.
Oh, advanced, okay.
And go to auth, and there's your username and password. Do they have a mechanism now for injecting cookies? I begged for that a couple years ago. Sometimes you want to inject a cookie when you're testing because you're testing as if the user had it right on their machine. And that could be a little hairy, injecting cookies, and sometimes when I use this this webpagetest.org tool and I need to inject a cookie, I'll go so far as to use Selenium to actually automate that. But that's you know, that's harder than it should be, right? It should not be so difficult. So this is a very nice tool, and short of a few things like cookie injection, basically, it provides the same results as you would get from any of the Gomez or Keynote products. The color coding is a little different, so if I ask you what color it is on the internet, for Yahoo, what color is it? Yeah, it looks green. Mostly green. And I cut the color coding off of here, so I apologize for that, but the green stands for the same thing that the blue did in the previous waterfall, right? It's the time it takes to get the data back, TCP transport times.
What's curious is that there's SSL negotiation for some JPEGs in my screen.
Ah, yep, I bet. You probably got very long T1 times. So the reason that those images are regarded as secure is because we're using them as beacons. Well, we're not. I don't work there any longer, but and haven't for many years. But
there's a PNG, a couple of JPEGs, and then there's
yeah. And boy, so this is really interesting. I wish I could show you guys the. Let me hold this up. Let me just. Love the air. Isn't the air nice? It's like the so I don't know how many of you guys can see, but this guy's waterfall has two long poles in it, right? So the first thing you want to look at when you look at the waterfall is what's the long pole, and that's quite literally which is the longest bar, which is the object that takes the longest to load, right? In this case, we can see there's two honking big poles in this waterfall, right? And they're both in this case for SSL connections for JPEGs. No, that one's a PNG, but I don't see why a PNG should take 2,544 milliseconds, much less 4,395 milliseconds. That seems excessive to download an image of any size on the web, right? I mean, really, if you got 5-second images, you need to call a designer, right? It's like this class is too advanced for that. Just go and get rid of the image. So, how many of you saw a big pole, something like he saw in your waterfall when you ran it on webpagetest.org? Yeah. So Yahoo is kind of famous for producing the long pole. I think that terminology actually came out of Yahoo because we saw them so often. Other sites don't necessarily produce the same number of objects with anomalous response times. Go and try B of A. Punched in, don't forget the HTTPS, right? Now B of A is a lot different than Yahoo, right? Don't have much on there. The only purpose for B of A's homepage is for you to log in, right? And the rest of it's just advertising. So I expect the waterfall for B of A to look a little bit different than it does on Yahoo, right? It's also secured. We know what happens with SSL connections, right? So let's test that. We'll punch in Bank of America, and let's see if they're plagued with SSL problems the way that I claim, or whether I'm just full of it. Use Firefox. By the way, when you're in the interface for webpagetest.org, use Firefox for this one. Yes, sir. Oh wow! Look for that.
No, I'm sorry. This isn't. This is still Yahoo.
Yeah,
I'm
this
just
is
curious
Yahoo.
as to you said. I'm just still wondering why there's SSL for JPEGs. You said that they're beacons. Is there a particular reason? I don't know why you would use SSL for certain images, but they are here.
So honestly, I'm not entirely sure why those particular.
We did it because on the browser you get like a warning if.
Oh yeah. So it's the dialogue. Oh, yeah. And as I remember, they went completely to SSL internally as well, and right? Yeah, they did KR3. That was the last one. So they use SSL internally within their network, and it's probably just easier to handle all those as secure connections. I mean, Yahoo and Google and everybody else is moving to do everything over SSL. What's that going to do to our performance, guys? Does that sound like a good thing? Everybody want to go to SSL for everything?
Yes. Yeah, let's do it.
Guys, I'm not kidding. We're going this way.
Better safe than sorry, though.
So this is, remember earlier I talked about making trade-offs, design trade-offs, right? We can either make it really secure and really slow, we can make it really fast and not secure at all, or we can strike some balance, right? Between what we think needs to be protected, right, and how fast it's going to be. Putting everything on SSL strikes me as little more than overdependence on encryption for security, right? Encryption is not security, right? When you use an SSL connection, you're protecting yourself against opportunistic attacks by hackers in Russia. Sure, that's wonderful, but it protects you not at all against the NSA. And honestly, if I have to take somebody on, I'm going for the hacker in Russia, man, because the NSA is going to win, right? It's like I want to be protected from the NSA, right? That hacker guy in Russia is not in a position to do as much harm, frankly.
Yeah,
right?
NSA's already hacked your router.
Right, and honestly, at least the guy in Russia is admittedly a bad guy, and he would tell me that if I asked him, whereas the NSA claims they're on my side. Well, they're reading my mail. Enough on that. Well, there's a round table on security and performance at for the conference here tomorrow. Obviously, yours truly will be ranting, raving, and otherwise going on about SSL and why it's not the solution to life, the universe, and everything. Anyway, did everybody manage to punch Bank of America into webpagetest.org? And make sure you put the HTTPS on there. If you don't, you'll get a redirect. So what's the first thing that loads on the Bank of America? It's not the web page. All right, so who did this with Firefox? Somebody picked Firefox? Okay, so what was the first thing to load on Bank of America? So what was it? What is the domain name for the first item in the waterfall? Let's be a little more specific. What is it? What's the domain name?
At the very sign.
No, that's the top level. What's the whole domain? evsecure-ocsp.verisign.com. Right, so most of you guys probably heard about OCSP for the first time today, and that's okay. It's hidden from you by the browser in most cases. Like I said, Firefox is the only one that exposes this. If you go and test Bank of America with the same URL using IE, you will not see those OCSP entries. And you will be wondering, why in the hell did SSL take so long? And you will have no way of figuring it out. Right? And that's very remarkable to me that I only have one tool to do this. But the first thing you see on the Bank of America is we make 2 OCSP calls. Before we're even allowed to make a connection to the server, the first thing we do is go and see whether their certificate is actually still valid. How long did it take to do those OCSP lookups? Somebody tell me. I talked to you earlier. How long did it take? Scroll up. So,
Which one?
so, no, okay. You did not get it. It was you that got it. No. Okay.
140 milliseconds.
Somebody still have it up here. Okay. So, right, so what was the total time by the time that was complete? It was 300 and something milliseconds. What about you? How many?
I didn't get that.
You're not using Firefox.
175, 300.
Yeah?
No, use it as a test engine, not IE or not the default.
Yeah.
Oh, okay.
Yeah. No, in the webpage test.org, you're going to choose the client used to perform the test.
Yeah.
I use Firefox.
I should have made that clear. No biggie. But Firefox is the only one that'll show you those OCSP lookups. So what did you get? You got 475 milliseconds?
For the verisign.com, 96 milliseconds.
And so there's 2 lookups. How much total?
120.
120. He's got about 330. 450. What have I got? Anybody got anything more than 900? Wow. So before I even send an HTTP request, I've spent 900 milliseconds asking VeriSign a damned useless question. So the way the cert chain works in the browser, the website gets a certificate from VeriSign, and that certificate is countersigned by an intermediate cert that's also usually signed by VeriSign, and that certificate is countersigned by VeriSign's major root cert. Right? So there's 3 certs in the cert chain. VeriSign's root cert is already on your machine in your browser's cache. Every browser comes with a cache of the top level root certificates for the major certificate authorities. They're already built into your browser and they're updated every week. Most people don't know that browsers go and download new certificates every week. But they do. They go through this whole process. So the root certificate for VeriSign is already installed in your browser cache. Out of 3 certificates, I only have to check 2. So I only have 2 OCSP lookups. Sir? I'm sorry?
Like here, the third one, which is moved to the Bank of America, is actually starting time-wise.
So let's think about how that happens. So that's a good question. So the point this gentleman makes is that the line that shows the loading of the Bank of America base page actually starts before those OCSP lookups, right? And so it makes the waterfall look a little odd, right? Looks like the third line maybe started before the first 2 lines. Let's think about what's actually happening there. So back to our model, the first thing we do is we go and look up Bank of America's IP address, right? Then we make a TCP connection to Bank of America. All this takes place before we have anything to do with certificates, right? We don't even know there's going to be a certificate, right? Actually, we do because it's an HTTPS URL, but even so, we don't know, right? And now we made a TCP connection. The first thing the browser does, well, the first thing that happens is we send a client hello message, which means, hey, you know, we need to talk SSL. I need to log in with a connection, right? The first thing the browser does is send me its certificate. And I read that certificate, and I see that I have 2 links in my cert chain. It gives me the URL to go and check the OCSP. It gives me the serial number for the certificates. I'm not actually testing the certificate itself. I actually send VeriSign the serial number, right? And I say, you know, so I went to Target, and Target's certificate has serial number XYZ123. Has that certificate been revoked? And the browser comes back, and VeriSign comes back and says, no, Target looks good. You know, they just let people rip you off at the POS. They don't need to bother with the SSL certificates, right? So what you're seeing there, when that line started, right? So when that line started, the first thing we did was that DNS lookup. And we made the TCP connection. We got the certificate. We started reading it, and only at that point could we go out to VeriSign. We didn't even know it was VeriSign until we had read the certificate.
So in that case, should the third line be the first one?
So you could say that first line should be the first one, right? And I kind of tend to agree with that. But the way that the webpagetest.org designers did it is they decided to put those at the top. It's an arbitrary design decision. If you look at CompuWare, when they do this, they order the lines more like you're thinking. Yeah. Now, there's exceptions and edge cases all over the place here, right? For instance, if you go to Google in webpagetest.org and use HTTPS, try it, right? The first thing you'll notice is that you only do 1 OCSP lookup. The second thing you notice is they're their own certificate authority, so they're calling themselves to do their own certificate lookup. The reason that happens is they're using something called OCSP stapling. They actually send the first of 2 OCSP responses back with the page itself, so you don't have to do it. Right? It's just a very clever way of avoiding OCSP lookups. And to be honest, the Google guys have spent many man hours trying to optimize SSL because it's the long pole in the loading of their pages at this point. And they've done wonders optimizing this stuff, but it's complicated. Like I said in the book, there's 60 pages on SSL, 11 different calls and messages have to go back and forth, certificates and OCSP lookups. Remember, every one of those OCSP lookups is an HTTP unsecure HTTP call. So it all has its own DNS lookup, and it has its own TCP connection time, and it has its own server duration, and it has its own transport time. And you've got to do 2 of these before you can send the HTTP request before the page that you actually wanted. Right? T1 is complicated, far more complicated than people believe. Anyway, are you started getting the idea of how to look at waterfall diagrams? Do you feel like you could look at a waterfall diagram for a random website, identify what the major performance problems were, identify any cases where there was an immediate error? Those are the 2 things that I want you to get out of a waterfall diagram. Do you think you could do that? Go to a random site, go to Amazon, use HTTPS, and then tell me what Amazon's performance problems are. And I'm not picking on them. They're great at optimizing things. They don't have any particular problem I'm looking for, right? But have a look at it. Tell me what you think their problem is. Use Firefox, use HTTPS. Tell me what color the internet is on Amazon. It's kind of an interesting test, actually. I can sort of sneak over here and watch you.
So which one are you saying?
Amazon.
Yeah, but which?
Use Firefox. Yeah, I recommend using Firefox for webpagetest.org. And you can pick, you know, whatever you like here.
Go to Oregon.
Okay.
So, America had a redirect. You had to go to www.America.
Actually, so to get around the redirect, go directly to HTTPS, and that way it won't try and redirect you.
You had to go to HTTPS www.bankofamerica.
Oh, I see what you're saying. Yeah, a lot of the times they'll put a redirect in there. So if you go to HTTP, they do a 302 back to the HTTPS. We do that on PayPal, and it's a huge performance hit. I pay 400 milliseconds right off the top for a redirect.
Right. No, it's true.
And the problem is there's no easy way around it, right? It would be nice if there was a DNS record that included the port numbers, but DNS is not really intended to do that, right?
Couldn't you just plot your SSL certs so if they came to why redirect?
Yeah, it's been proposed. There's a field in the SSL certificate where we could stuff that.
So now we don't have to do that. So that's what we do for our stuff.
The problem is that the fields in the SSL certificates are getting stuffed full of crazy stuff everywhere. I mean, so server alternate name is another field in the SSL certificate, and it's really there to originally to provide websites with a means of specifying alternates, right? So if you were at a.yahoo.com and you wanted to include b.yahoo.com, you could just put it in server alternate name field in the thing, and then you didn't have to get another cert for that, right? Interestingly enough, and this is a performance trick, and these are very few, performance trick known by the Facebook guys, unknown to the Google guys. If you put your CDN star.domain.com for your CDN into the server alternate name field in your SSL certificate, you will no longer have to make OCSP lookups to your CDN. Right? So the Facebook guys discovered this. I don't know how exactly. And I was looking at their waterfall because I use these big sites as examples in my book. And I was looking at their waterfall and I'm like, is this SSL? I don't see any OCSPs. What's going on? And so I had to go back and look, and it took me maybe an hour and a half, 2 hours to figure out what they had done, right? At first I had to confirm that the OCSP lookups weren't being cached somehow and that they really weren't being made. And I went through this whole thing and I discovered that by changing this one field on the form when they filled out the form for VeriSign to get their server certificate, they were able to eliminate the OCSP lookups to their CDN. The Google guys have not figured it out, but I figured that within 20 minutes of this class ending, they will.
So how did they do that? Sorry, could you say that?
They added their CDN's domain name to the server alternate name field in their SSL certificate. So it's a little bit complicated. I don't want to try and explain all those buzzwords, rammed together as they are to you. But basically, there's a little field in there that allows you to use the same certificate for multiple domains. And the Facebook guys took clever advantage of that. And I was really happy with that. A, it's very clever. B, it works really well. You'll see that they don't do as many OCSP lookups. And third, sometimes it's nice just to see something new in the performance space that wasn't done by Google. Right? I mean, they do sort of take up some of a lot of the oxygen sometimes, you know, and it's like they do great work. But I'm also glad to see other people contributing to the industry as well. Cached versus uncached. Gentleman back here mentioned this earlier today. There's no bigger difference in the performance of loading pages. Here I've just got two waterfalls. One is for an uncached and one is for a cached version of PayPal.com. You're in my favorite site. Everybody does have a PayPal account, right? Don't tell me you don't have one. I mean, I will throw you out even though the class is almost over. No, I'm just teasing. Seriously, cached and uncached. For uncached, obviously we have to laboriously download every object. Sorry, this is actually Yahoo. This is not PayPal. I guess I substituted it. Maybe somebody complained. But this is Yahoo. You can see that they start downloading the Earth there and basically download every image on the CDN somewhere between there and the end of the page. I mean, is that ridiculous? Come on, guys, like 70 or 80 images. But when it's cached, it looks like a normal web page. Right? I mean, that's sort of what we expect to see from normal web pages, and that's sort of the uncached version of yahoo.com. But you can see, if we think about counting the number of connections we have to make these connections is roughly 80 connections are required here, 80 objects, 30. So 5 over 8 is about 60%, right? So 60% of my stuff doesn't have to be downloaded and is now cached. On a byte basis, per byte, not per object, per byte, 95% of the bytes are cached because the bytes are in the static images, right? The work being done transporting this stuff over the wire is largely done by or taken up by those static objects. Right? So by caching and using caching wisely, and the Yahoo guys are very smart about this, and a lot of the caching header mechanism was actually developed by guys at Yahoo. I had nothing to do with it, but some really smart guys back there worked on things like how expires actually works, things like that. And they managed to eliminate 60% of the web page by objects, 95% of the web page is cached on a byte basis, and everything that's left here is stuff that is actually active or dynamic on the page and can't be cached. If you're wondering why all these GIFs are still there, those are beacons. They're attached to a dynamic process. They're measuring something like, you know, omniture data or something like this. Can't be cached. Caching is the real deal. Everything that happens on the web is about caching, whether it's caching on your machine, in the client, on the browser, whether it's cached at the CDN, on some intermediate proxy. Everything is cached. Everything in phase 2, remember our phase loading of the web page, right? First we load the base page, then we do the intransitive hyperlinks, right? The static objects and the deferred stuff. Everything in phase 2, right, can be cached. There's no reason for there to be a phase 2 in the load cycle for a cached page. Caching eliminates that whole phase of the browser loading cycle. Is that amazing or what? Right? Make sure and use caching wisely. Go read about those headers. They don't make a lot of sense the way they're written, and everybody recognizes that, but the whole web is full of cryptic stuff. Don't let that get in your way. Right? A little bit of thinking about how we might do testing. So now we know how to test a web page. That's nice. But web pages are just so 1990s. I mean, we don't even really have web pages anymore, do we? And then there's that Ajax thing. It's like, where does the page load? Oh, man. So I used to give a talk back in the early 2000s called Thank You for Breaking the Web. Right? And it was all about Ajax and changing the load model for the web and the way things change. So measuring web pages is not all that useful anymore. I mean, we still need to know how long it takes them to load and everything, but remember back when we talked about the systemic qualities. Performance wasn't about response time for a web page. It's how long it takes the user to do whatever in the heck they wanted to do, to accomplish some task. And that task might involve several steps or several pages or some combination thereof, right? This particular map is a map of, come on, you can guess. Having listened to me all day, what is it? Let's see, inbox, read message, send confirm, compose. I wonder what those, let me see if I can think of an app that has, okay, so this is Yahoo Mail, duh, right? And what we wanted to know, we had a problem. People on Yahoo Mail were logging in to their mail purely to dump their spam folder. And it was like 40% of the accesses on Yahoo Mail were people accessing their spam folder to dump it. And we're sitting here scratching our head going, what the hell are these people? I mean, is there like some spam folder virus going around or something? What the hell is actually happening? Why are people logging on to us for the sole reason of looking at their spam folder and then going away and dumping it? And so we couldn't figure it out for a long time. And I used this technique called task analysis to figure out what was going on. And in the end, besides all the good performance data, what we learned is that people were not logging in order to dump their spam filter. People were logging in because some piece of mail was lost in their spam folder and they wanted to retrieve it. They just dumped their spam folder on the way out because might as well, right? It's all spam, right? And that's what we learned about user behavior and the tasks that they were trying to complete. Once we realized what they were doing, we made it a lot easier to go into the spam folder and dump it. Right? And we put some search capabilities in there so you could identify that one email that was actually worthwhile in the mountain of spam, and went and designed things to make it easier and make those tasks complete sooner for the users. And that's real performance work. Here, I actually looked at how long it took to go from any given state to another state. So you go to a welcome page, then you go to your inbox, might go to a read message, you might go to your bulk mail, your spam folder. These numbers here are just probabilities. I dug those out of the log files, right? Out of every 100 users that comes to that web page, 35% of them go to compose, and the probability here is what it is. So now I have these probabilities and I know how long it takes to go from one page to the next. Right? So I just looked at the paths that the user took through the system. Most people come in, compose an email, send it, and leave. Other people come in, check their spam folder, find the message, and dump their spam folder and leave. Whatever it is, they're accomplishing a task. And that task requires several steps. Maybe they're web pages, maybe they're not, maybe they're handled by Ajax. Odd Post was the first really to use that. No, it was not the OWA guys. I went in and I was able to figure out the response time for tasks. How long does it take you to compose an email? Now, I have no idea how long it's going to take you to sit there and type stuff and whatever, right? But I can tell you how long it's going to take to get to that page, how long all the tasks you're going to have to do to get there. And other than your own client think time, which I can't do much about, I can tell you how long it's going to take. And I can do that for any of the tasks that you can do in this application. And if I want to do Farmville, and I saw somebody do this for Farmville actually, right? They did task analysis. I actually came to my class and did the task analysis for Farmville. Of course, they worked for Zynga. It worked out really well for them. They were able to redesign the app so that you could do a lot of things more quickly. But every app, you can divide it up into a set of states, decide what tasks you want the user to do. If you wrote that app, you should have that written down somewhere, believe me or not, right? And you can figure out what the time is to accomplish that task, and that's the response time. It's not the response time of those individual pages, it's the response time required to finish that task. If I have to visit 11 pages to send an email, and in 2014 I don't, but back in the Hotmail days I kind of did sometimes, right? That's the response time. That's how long it takes me to send an email. And that's all that matters to me. I don't care as a user about web pages or Ajax or images or any of this crap. It's like the TV. I turn it on, it comes up on my screen, I do the right thing. When I'm done, it goes away. It's not slow, it's not broken. And that's what I was trying to do here. I was trying to get at application performance rather than individual page performance. And this is one way of going about that. When the fellow went through and did Farmville, it was really very interesting because he found, and I don't remember the details, I'm not a great Farmville player, but there were things that he wanted to do in the game in terms of like cultivating his land or whatever that took 3 or 4 steps and turned out to be the most frequent things that users wanted to do. And they just rearranged the UI to make them surface them. Only 1 step, not 3 or 4. And that sort of design is the real performance work, right? Fiddling with the packets, that's useful. It's important, right? But I'm not going to go fiddle with PAL or NTSC if I want to make a movie better, right? It's like more about how do you design your website to make sure that tasks get accomplished quickly. At PayPal, we have this login, review, confirm sequence that you have to go through to make a PayPal purchase. We did everything that we could. We did this analysis several times on that in several different ways because people had some alternate ideas from this one. And we analyzed that sequence in multiple different ways, and we found some ways to improve it. If you guys noticed, sometimes it used to be on eBay when you bought something, they would redirect you over to PayPal, you did your business, and then they would send you back to eBay. Now we inlined PayPal right into the eBay page. I don't know if anybody's had this experience. It's been out there for 18 months or more, so I hope you have. That came out of this sort of analysis. All that time spent going from eBay to PayPal was a complete waste of time. The user was just aggravated doing that. We eliminated it. And that came out of this sort of analysis, task analysis. What is the user trying to do? Give up on the web pages, you don't care. There's states. Right? This is how you solve the AJAX problem when the URL no longer matches the data structure described by the original HTML object. And that's really what we're talking about, right? AJAX allows us to modify the DOM in real time, right? Make HTTP requests and responses in real time outside the normal page loading process. So we can't talk about pages anymore. We got to talk about states. And we got to analyze those states, look at the probability of the users going from A to B rather than B to A or whatever, work out how to optimize those paths that are the ones the user really likes to take. Testing your competitors for fun and profit. I promised you this graph earlier. So these are, once again, all the folks in the top 100 that take SSL. And you see there's this big step function right here that starts with our friends at Twitter. And everybody over here on this side of this graph has roughly similar SSL connection response times. Everybody on this side has roughly similar SSL response times with the exception of Tumblr. And this was before Yahoo bought Tumblr, so I think that this was at a time when it was still in David Karp's basement, right? It was literally in David Karp's basement at one point in time. So we're not counting Tumblr up here so much. But isn't it very remarkable that the SSL response times for these folks are also very similar, and for these folks are also very similar. So I went looking, I was trying to figure out why eBay and PayPal and eBay, that should have been my clue there, and Wikipedia and Twitter all saw response times that were roughly 200 milliseconds greater than all of these other folks. It almost looks like I have a class system going on here, right? Upper class folks go fast. You know, these folks got sent to the back of the bus, right? It's like Brown versus Board of Education. I need my SSL to go faster, right? Prejudice. No, it has absolutely nothing to do with it. What is happening here is that those folks that are taking longer are using 2048-bit extended verification certificates. And these folks that are getting good SSL times over here on the whatever the hell that is, the left-hand side for you, they're all using 1024-bit certs. So this is real live data on the difference in performance for SSL certificates, right? The government, bless their little hearts, wants you to go buy a 2048-bit cert, and they're going to start requiring that. What's going to happen to our performance? Right, we're going to lose 150, 250 milliseconds off every connection at the top. Right, just like imposing SSL is going to cost us about that same, right? We are going to need HTTP2, guys, just to make up for the performance and response time that we lost by adding SSL. And it may turn out to be a wash. That doesn't sound so good, does it? That wasn't what I wanted out of my brand shiny new protocol, let me tell you.
Discern which certificate is being used?
So for these people with the higher times, this is an EV secure. In some cases, it's VeriSign, DigiCert. It's marked up there. In most cases, they're VeriSign. And in fact, if you look, 2048-bit EV certs are 80% or more generated by VeriSign.
So it's the traffic to VeriSign that leads you to the conclusion that they're using a...
No, I can see it on the certificate. Yeah, I can just outright see it, right? So click on the little green key on your URL bar. It'll tell you everything you want to know about the SSL certificate you're using. Actually, it'll tell you far more than you ever wanted to know. The only thing you really want to know is look for either 2048 or 1024. One of those two numbers will be there, and depending on which number is there, you can guess how fast that connection is going to be, or not. Right? I did not see vast differences for cert length among the various certificate authorities. VeriSign, DigiCert, GoDaddy, Thought and VeriSign are now both owned by Symantec, by the way. But I did not see that the vendors themselves had huge variance in the SSL response times. What I did see was that the length of the cipher key for the handshake really made a huge difference. And that's probably mostly due to the asymmetric encryption that's used for the handshake. The point here is not to rant on even more about SSL. I mean, I've ranted on about SSL enough for the day, trust me. What I wanted you to see here is how you can go about testing your competitors in a way that makes sense, right? A lot of times competitive testing is done really poorly. It's very expensive. It's difficult to do. Doing these tests over some long period of time can get really expensive because the pages break. Right? The B of A changed their page, and oh, my test doesn't work, I've got to go fix it. The competitive testing can be very difficult, very expensive. It's also very worthwhile. When you look at this, I went to look at my competitor's SSL, and I learned so much more about the way SSL works on the web and what it does to performance than I ever expected. I never expected when I saw this that I would see a step function based on key length in the certificate. That never occurred to me. So, testing your competitors, often very worthwhile. Okay, so one more thing on testing, and then we're gonna close it down because I'm really over time. Global performance testing. I want to test Argentina, and I want to test Armenia. I just needed something with an A. Right, so I'm going to test Argentina and I'm going to test Armenia, and I'm going to compare those two data sets, and I'm going to say Armenia is faster than Argentina, or maybe Argentina is faster than Armenia. Is that valid? Is that a valid comparison? Yeah, it's not. It's fruit to fruit, but it's not really apples to apples, is it? So how do you get to the point where you could actually compare apples to apples? I mean, your boss is going to come and ask you how fast it is in India, right? And what are you going to say? I told you earlier what the right answer to that question was. Come on. Right. So how do I make a reasonable comparison to India? Right? I can't compare India to Silicon Valley. I mean, somebody's being arrogant there. I'm not sure whether it's the Indians or the Silicon Valley people, but that's not a valid comparison. Right? I need to compare like with like. Fruit with, apples with apples. I cannot compare performance data out of region. Now, I can compare Italy and Slovenia. They share a border. They share similar infrastructure and history, right? History determines web performance, believe it or not. Right, but I can't compare Argentina and Armenia. I might as well compare Mars and Venus. All these different factors, bandwidth, ISP, infrastructure, secular cycles. Does your ISP know how to run a DNS server? Right? Trust me, in Argentina, they have very little knowledge about how to run DNS servers. I did not pull that one out. So I needed a way to do this because, of course, somebody asked me what to do about Argentina and India and all the other world countries, and I had no way of comparing them, so I had to give it some thought. And I came up with what I call the Stormcat system. Basically, I find the dynamic range of performance measurements across the places that I want to measure. Right, so best case, Northern California, high broadband line at 3 a.m. That's probably about as good as I'm going to get for an end user, right? How much better is it going to get? I guess I could stand in the data center, but that's not fair. Worst case, rural Indonesia on the world famous VSNL ISP. Any Indian person in the room will be laughing because they know all about VSNL. At 2 p.m., which is, rush hour in Indonesia, right? This is worst case. And so I basically take the dynamic range of performance measurements. I divide it up into 5 buckets, just like the guys on the Weather Channel do. And they have their Category 1 storm and their Category 2 storm and so on. So I'm going to create Category 1 websites and Category 2 websites. And the way that I'm going to do that is I'm going to take the dynamic range, divide it up into 5 bins, and let you compare response times only within a given bin. So if you have typical response times around X, and Argentina has reasonable response times around X, that's a reasonable comparison. But I can't compare Yahoo and Armenia and Argentina. It's not fair. But by comparing like with like and using this what I call the Stormcat system, basically I've basically ripped off the meteorology department, right? Because this is how they do it too. I mean, there aren't any absolute measures for storms. How could you figure out how strong a storm was? So they just took the weakest storm and the strongest storm, divided it up, and then they could compare storms over time. So this is the only way I know of to compare like with like for international data. If you compare it any other way, it's probably invalid comparison. Our last anti-pattern, you've heard this one before, so I don't have to spend too much time on it. Performance is a design time activity. Bake it in up front. If you launch something without testing it for performance, you deserve a spanking. Seriously, right? It's like this is unprofessional behavior. But you would not be surprised, probably not, you're in the industry, about how often that happens. And in fact, my own company is not innocent of this. We've launched multiple products without bothering to test it first. In some cases, this is really bitness. In one case, we actually launched an SSL-based product with no certificate installed at all. Should have tested that. Yeah, I mean, what do you think happened there? Right? So the client has two choices when it tries to make an SSL connection. There's no certificate. It can fail. It can go forward. Those are the only two choices. Which one's worse? Going ahead would be worse, right? I want the client to fail. It's like no certificate, no money, right? But no, in this case, the certificate was designed to, oh, no certificate, we don't care. Go ahead, make those PayPal payments. And, it was only in production for about 25 minutes before somebody figured it out, right? It wasn't a huge thing and whatnot, but we would never have launched it if we had tested stuff first, and it was so easy to find. I mean, as soon as they told me the product was launched, the email takes a little while to percolate down. As soon as they told me the product was launched, what did I do? I went and tested it, right? Punched it into my performance tool, tested its performance. Bingo! I knew immediately in the very first test that something was really, really wrong, right? And the way I knew that is because we were faster than Google, right? And I know that's not even possible. Right? So I knew something was seriously wrong, right? And what it was Google was using SSL, so of course they're slow. We neglected our SSL certificate. Client said, we don't care about SSL, passed it right on. Suddenly we were faster than Google. For 5 minutes I was really gratified. And then of course reality came back, right? And now Google of course is rightfully about 5 times as fast as we are, and that's okay. But for a minute it looked good. All right. I'm not going to touch the HTML5 stuff. We just do not have time for this. It will be in there. Mobile stuff I do want to touch on. So, bottom line, native apps versus HTML5 versus desktop. Everybody knows there's a big controversy about this, right? Native apps versus HTML5, right? Anybody that's following the HTML5 thing, I mean, it is an HTML5 conference, right? So everybody kind of understands native app versus HTML5, right? So where do you guys fall? Native apps? HTML5? You already voted twice. That's 3 votes. You're only one person. What, are you like a redirect or something? So let me see once again, let me see the HTML5 people. Okay, so here's the bottom line on this, right? The native apps are faster. I think everybody knows that. They're going to stay faster, right? We can make the HTML5 apps go faster than they do now, but we cannot approach the performance of a dedicated client. When you say app, what you mean is dedicated browser, right? It's a browser written to handle those particular kind of HTTP requests and responses. It's custom written by some expert to do just that. Of course, it's always going to run faster than your generic HTML interpreter, which has to interpret any kind of junk that comes in, right? So the app writers cleverly leave the hard work, writing the browser, to the folks at Microsoft and Google, and they go off and write these very simple, lightweight, dedicated browsers, and we call them applications. And that's great. I'm very happy with that. I love my apps, most of them. But I'm never going to be able to make my native app run that, or my HTML5 app run that fast. And I know that, and so I'm looking out here at people, and people are like, either he's lying or that really sucks. And I hope he's lying, right? Because a lot of you probably have HTML5 apps out there. It's okay, right? We have HTML5 apps out there too. We consciously measured the performance of it, went into it with our eyes open, and decided that HTML5 offered us a lot of benefits in being able to update apps, rewrite apps, load apps onto new devices that we couldn't get with if we had built a native app. We consciously made that decision, trade-off, portability, extensibility versus performance, and we decided to go for the extensibility and the portability instead of performance. So our app is a little slower than it might be if we had written some custom dedicated thing, but we decided with our eyes wide open to make that trade-off. So when you think about native versus HTML, I don't want you to make some trade-off based on, some article you read on Tom's Hardware or something like this. And I mean, I've got a nice graph from Tom's Hardware here somewhere. Right, so I think this is, or maybe it's this one. Yeah, never mind, it's in here somewhere. But be that as it may, I don't want you to make these decisions based on something like that. I want you to make the decision based on the trade-offs that are right for you and your company, right? For Google, they may very well say it's of the utmost importance for us to absolutely get this to the user as fast as we possibly can. We're going to write a native app. We're going to tear up the rug and do everything we can to make this as fast as possible. PayPal may very well say, we're in the middle of the road in performance. We're willing to trade that off because we're super secure. And your money is safer in our cloud than it is in your wallet. Not very many people can say that. So we made that trade-off, right? I don't want you to give up on this stuff and decide that because native apps are always going to be faster. Say you're going to give up on HTML5. Absolutely not. What I want you to do is be aware, quantify those trade-offs. Make it with your eyes wide open. That's what you're doing. Is it really important to be super fast, even if it's less secure, or less extensible, or less secure? Right? Developers have an interest in here too. If they have to rewrite a bunch of iOS 5 code, they have to change their app as opposed to modifying the HTML code. You bet they're going to have to do. Right? I mean, they roughly paid the same for whatever they write. Which one would you rather write for the same? Right? Let me briefly go through here. So that's the story with native apps. Right? They're not going to exceed these performance. I lost the battery. Okay. That's probably a sign. That's probably a sign. So I'll talk loud for a few minutes and then I'm going to let us go because I think we really are over. And I'm sure Ann will come storming in here with a pitchfork, maybe a torch too, and throw me out. I don't get out of here quickly. Mobile apps are slow. Compared to desktop apps, this is no surprise. We talked about mobile being slow throughout the whole thing here. Right? So here's Ilya's quote, 2,000 milliseconds of latency on a 3G network, and that's before you get to T1, T2, T3, and T4. Right? That's in addition to the normal load. Slow compared to web, we heard that before. I wanted to point out how much better apps have gotten, how much better the mobile devices have gotten, because even as slow as we claim them to be, we have exceeded Moore's Law in our performance growth. Now, we did not double in performance over the course of 18 months. We actually exceeded it by a factor of 4. Right? That's pretty remarkable. So when you talk about mobile apps being slow, well, yeah, it's slow compared to your desktop. It's been under development for 20 years. But compared to your phone last year, it's not slow at all. Right? I mean, people think that, Moore's Law is like the upper limit on that. Speed on mobile devices for web pages has exceeded Moore's Law in its improvement. So don't give up yet. Right? Never going to be as fast as your native app, but don't give up yet. Factor of 5 for JavaScript, 4G and LTE, those things are not the same, but they pretend they are. Right, they're about 27% faster. So if we pay 2,000 milliseconds for 3G, how much do we pay for 4G if it's 27% faster? 1,440 milliseconds. Right, all I did is just multiply. Right, it's like 27%. Right? So What does that mean? That means that our 4G or our 3G devices are going to be that much slower than our 4G, and we're going to have to support them for how long? Maybe 5, 6, 7 years. It's going to be a slow, unhappy summer having to support 3G devices in 2017. Nobody's looking for it. So this is from 2012. This is the most recent data I can actually find. People are really, really reluctant to publish performance or mobile data. Even more reluctant than they are to publish WAN data because the performance data on the mobile devices is often correct. Right? So once again, you don't need to quantitatively get the numbers here. All you need to know is this is your 4G phone, this is your fiber connection, and eyeball it. Right? What do you think? You're going to go home and sit in front of your computer, right? So just to give you an idea here, the yellow or gold is the US, the orange is the UK, and the blue is Australia. And actually this graph was originally provided by some ISP, guess what, in Australia. They have better bandwidth than they do in the UK and the US. Right? Now I don't necessarily believe that, but the numbers are as close as I could find to what I've seen elsewhere in Gartner. And I thought it was just funny that the Aussies had to put it like that. Users expect more, and they expect more now. Right? It used to be that over that 20% of the users would bounce. Now 75% will bounce. This is what I was talking about earlier, right? Your users to expect the pages to go faster. You know, they bounce. Mobile JavaScript can put in terms of performance. So remember I said there's about a 5x difference between HTML5 and code for JavaScript. Where is that 5x? Is it in, you know, code interpretation, type arrays, whatever? It's really in the garbage collection. And it really is. Garbage collection for Java, for JavaScript, for Scala, for these languages, interpreted languages. You don't have to do an algorithm that works well for garbage collection. Either place. Not enough, not opportunistically enough for 2 opportunities. It's very difficult to get that right. And the little mobile devices have not done a great job. For that matter, the desktop hasn't done a great job. They just have lots more memory usage. How the network works, I will let you study this at home in your leisure. The important point I wanted you to get out of this was compare this diagram to the previous diagram where I showed you how your WAN or your LAN network works with your home router and everything. Where does the mobile network differ? Are there different steps? What's the difference with the mobile network? And you'll see immediately that there's one small step in the process actually occurs in T1, surprise, surprise, where there's a serious difference between mobile and WAN networks. And most of the difference in performance between the two is around the T1 connection. Migration, it's not going to happen very soon. Bottom line, we're going to be supporting both of these kind of devices for a while. New features for mobile, HTML5 has got them. We really spent a lot of time in the HTML working group trying to think about what mobile users wanted. This was a change. HTML working groups, I've been a member of that working group since 1996. It got a little bit high down. By the time I had published HTML modularization, I think most of the group was asleep, or at least sleepwalking. And the Googles and Mozilla's of the world came along and woke us up. And now we're actually paying attention to things like mobile. And so there's a lot of features in HTML5 that are designed specifically for mobile, that are designed specifically to address mobile concerns. A little bit of food for thought. So Nick Sakis is the guy who wrote that Yahoo webpage. The main page. And he was the lead developer. His name is Nick Sakis. He's got a book out there against high-performance JavaScript. And he knows a thing or two about performance. And he put this nice diagram together. And it's really important for you, more important than the why slow rules maybe for you, when you're constructing web pages to make it fast, is using the right tool. Don't use HTML to do things that CSS can do. Don't use CSS to do things that JavaScript can do, right? Those are the two cases that I normally see. And part of the HTML part is habit. Some folks actually started reading HTML with things like bold and italic and stuff were valid or semantic modifiers, right? I did, right? When I started writing HTML, we did our tags in uppercase. Yeah, I know, I'm dating myself here. But I used to go to conferences, so we changed that with HTML4, right? And we just said outright, tags have to be lowercase now. And I used to go to conferences or talks like this, and people would protest. Maybe they would be standing outside the room going, lowercase, lowercase, lowercase. What is wrong with you? And changing HTML lowercase was traumatic. Use the right tool for the right job. Don't try to do things in HTML you can do in CSS. Don't try to do things in JavaScript that you can do in CSS. Right? Make sense of it. Keep it separate. Best practices, I'm going to let you read those. Takeaways, these are a little more important than those so-called rules. Right? They're always going to be slow. And it's not always about the JavaScript. Design the things that have delays in them. We don't normally design things that way. We design pages as if they're going to go as fast as they possibly can, and when they don't, we're surprised. But we know on mobile devices that the page is not going to go as fast as it possibly can. There's going to be appreciable delay. Right? Why not design things with the delay implicit in them, build the delay into it, build the user will get a better experience, right? HTML5, like I said, designed for mobile, use it wisely, right app for the right job, right design patterns for mobile. A lot of the things that we do, the actual patterns that we do on the desktop just don't make sense on mobile devices, right? I mean, your code may go to a bridge, right? You can cut off. And that password you just carefully type in on your mobile device is a person. You have to type it in on the building so you can really see. Right? Don't design things from your desktop and try to shove it on your phone and expect it to work. Don't expect the same design patterns to be used on your desktop to work. It's a different device. It's not a tiny desktop computer. Tools for mobile testing, we did not get to this. I want to suggest these. Hopefully some of you did manage to download this onto your phone. You can test these things for yourself. Speed test is the same as speedtest.net. iCurl, we looked at that earlier. I used it with this gentleman to do our measurements earlier on Twitter. HTTP Watch Basic. So this is a mobile waterfall. The only difference between this one and the other waterfalls is I'm using my iPhone. And so what is this? Oh, it's my favorite website again, Yahoo. You know, I haven't worked there for 4 years. So of course it's still my favorite. No, of course, seriously, this is what Yahoo's page looks like on mobile. What's the first thing you notice? Damn, it looks a lot like the same waterfall that I loaded onto the desktop. Are they even loading the page different? Are they just cramming that desktop crap onto my mobile phone? Surely not. And then you go and look and you find out, yes indeed, it's the exact same page that got delivered to the desktop. And then they wonder, why is it so slow? Use these tools and you'll be able to get a really good idea of what your mobile performance is. And that's precious data. It's hard to get. Not very easy to test it. Before we started getting these tools on the App Store, I was learning to doing things like rewriting the software on my AP, my wireless AP, so that I could put like trace route stuff in there and measure it at the AP. Very valuable. Anti-pattern, it's the application. Is it? Let's read this. It's the application, stupid application. Think here, right? We know it's not necessarily about T2, right? 35% of the total end-to-end, that's pretty good for desktop. Server duration going to be different on mobile? Yes, it's going to be different. Not because your server's doing more work, but because it's generating a different page. It's hopefully designed for mobile. In the case of Yahoo, I think we decided that, or we determined that it wasn't. Anti-pattern here, failing to recognize that the mobile EDE is very different than the desktop EDE. The different proportions of T1, T2, T3, and T4 are very different on mobile devices. Different piece of machinery, so I'm not surprised that that happens. But people act like the performance profile on this device is the same as it is on that device, and all they get from that is clean. Don't do that. Analyze the MPPC numbers, whatever device you're talking about, go work it through. It's really simple. Don't expect it to be the same. Okay, so in the year 3014, which is when I'm coming back to do this class again, right, the Japanese have completely re-engineered Mount Fuji, right? And there's no more sun or springtime or anything because, of course, global warming has kicked our ass and there's no more sunlight. Right, so this is what Mount Fuji looks like. 7 rules for making things faster. These are rules for you, not for websites. They're for you, right? Make it a priority, test it, learn about the tools, balance. We talked about that a lot. There's trade-offs. Track the results over time. Set the targets. Ask questions. Check it for yourself. Tony Toyer, the manager of the exceptional performance group, got it. Just hold your slide up. So just looking at these 7 performance principles or habits or whatever, have we talked about every one of these today? Do you feel like we've hit these? I hope that we have. I think that we have. But I want you to feel like that as well. The why slow rules. Better yet, go by Steve's book and learn why they're like that. These are the set of rules from high-performance websites. We came up with these, I think, in 2003. At the time I left Yahoo in 2009, we had 115 why slow rules, something like that. Of course, we didn't publish all that. All that would do was confuse the hell out of people. We left it 14. But there's a lot of these. And what these are heuristics, right? This is condensed, distilled experience of the folks at Yahoo having seen thousands and thousands of web pages and performance problems. These are the things that we wrote. If you go over to Mountain View, you'll find that they're taking you back to small. You might want to think about that first. Right? The other thing that I just want to talk about was tools. So in past life, I was a cosmologist, kind of astronomer with long hair. And over the course of my career, I had to look at data from all kinds of different telescopes. And I didn't spend a lot of time worrying about, I love this telescope, I really hate that one. I looked at all of them. Every performance tool has its place in the universe. It's not that this tool is your favorite, you're going to use it. If you get, so that's almost an anti-pattern. I'll add that as an anti-pattern next year. Don't fall in love with your tool. Right? It's not a black and white world. Right? You can't afford to believe in your side. You can't afford to believe in your tool. Right? Every tool is valuable. Figure out what it does. Use all of them. And don't let anybody be deceptive about it. So, I asked you earlier what you do when your boss comes in and talks to you about performance and tells you that to make things faster, right? So the other question I get from bosses is, how fast is it? Or how's our website doing today? And I always have a stock answer to that, right? It's like, when's that project going to be done? How fast is our web page today? How fast is our web page in India? When are you going to be done with that book, Daniel? All of these have the same answer, right? 42, right? When your boss asks you a stupid question, 42 is the right answer. How fast is it? Right? Seriously. You have to educate upward with your executives and your bosses, right? Don't say 42 unless they've read the books. They won't get it. Right? In your head, just say it and carefully and calmly explain that's not a reasonable question. Let me explain what we need to ask me in order to get the data that you want. And maybe you'll understand something about performance. In the course of that, you're going to ask questions. 42. So the last slide here, if you were looking for somebody to blame. Right? You want to know who to blame for all of this good stuff? Right? HTML and HTTP, so forth. It's Tim's fault. Quite literally, it's Tim's fault. Bob Kailau, the guy that's mentioned here, left CERN, I think about 4, maybe 6 months later, and never really popped up again. He never played any huge role. It really was all down to Tim. And the reason I can tell you that is that because I was there. I was a postdoc at CERN in 1990. And I ran into this guy named Tim. He had the office right down from mine. That's why I don't do physics. And if you want to know, I just tell people it's all been downhill ever since I got Tim, right? But if you want to know who to blame, right, it's Tim's fault. He invented the whole thing. Performance is about respect for yourself, for your users, for the people you work with, for the industry. Thank you. We're done. I'll stick around.